Good afternoon, everyone. Welcome to our Predicting Ocean Temperatures for Reefs webinars. For those joining us for the first time, welcome. And for anyone who has joined us for one of our webinars before, welcome back. Today we'll be discussing how we monitor ocean temperatures and what is currently happening and why it matters. My name is Jordan and I will be your moderator today. I am joined by Claire. She will be producing today's webinar. Together, we will make this webinar as interactive as possible. But before we start, we'd like to ask for your attention as we cover off some housekeeping items. So obviously, with the situation as it is in Australia, this webinar will be conducted from our respective homes. Please bear this in mind as we may encounter some technical difficulties during the broadcast. Our presentation today will run for 60 minutes with plenty of time allocated for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time webinar attendees, please see some helpful tips on your screen. Most importantly, please note the chat box where you can send through any questions or feedback for the presenters. Please use this and not the Q&A box to send your questions to us during the session. We don't see the ones in the Q&A, so please chat box, and we will answer as many as possible during the allocated breaks. You can start sending them through now if you like, or test it by telling us your name and where you're dialing in from. In response to feedback received from previous webinars, there is some information on how we participate in our polls. So when a poll is in motion, attendees will see a set of questions on the right of their webinar screen. Please select your answer followed by the submit button below them. It'll also take a moment to thank all of you, those who sent in questions during your registration process. We have developed the content of this session in accordance with the common themes of those questions. So thanks for engaging with us. We really appreciate it. And finally, I'm delighted to introduce the people we can't do this presentation without, our presenters, Dr. Claire Spillman and Dr. Grant Smith. Hi, guys.
Hi, everyone.
Hello, good afternoon.
Okay, that's the first big hurdle jumped over. We have audio. Dr. Claire Spillman holds a PhD in environmental engineering and is a senior research scientist at the Bureau. Her current research is primarily focused on seasonal forecasting for marine applications, particularly for coral reef and fisheries management. Dr. Grant Smith, on the other hand, is a senior research scientist also at the Bureau and is primarily involved with marine seasonal forecasting for sub-seasonal to seasonal timescales for both Australia and Pacific. And if that sounds a little bit confusing, I'm sure the guys will explain it a little bit later on. Just a note, today there was some news that came out about the Great Barrier Reef from the Marine Park Authority, so it's great timing that we have these guys on today. We'll be talking about how we're helping them manage their reefs. So, hello guys. Claire, would you like to start by telling us what we'll be hearing today?
Great, thanks Jordan. Welcome everybody. So today we're going to give an overview of how we monitor the oceans, specifically ocean temperature, the ocean outlooks that the Bureau produces for Australia, and then delve into how we predict ocean temperatures that cause coral bleaching, and also how reef managers and other marine stakeholders use our forecasts.
Oh, excellent. A lot of interesting stuff to look forward to, guys. But before we get stuck in, we thought we'd do a quick poll. We'll be talking about the Great Barrier Reef later in the presentation, but do you know how big it is? The question is, how big is the Great Barrier Reef? Is it A, the same size as Tasmania, B, Victoria, C, Switzerland, D, United Kingdom, or E, Italy? While you get your answers in, we'll take a question or two, starting with Sue. And we'll throw this one to you, Claire. She wants to know, what effect does El Nino and positive IODs have on the reefs?
Right, so El Nino causes warmer temperatures in the Pacific and around Australia, and is usually associated with a drier, warmer summer over the land, and also warmer temperatures over the Great Barrier Reef. So in the past, coral bleaching has occurred during El Nino events. Not all bleaching happens during an El Nino event, but a lot of the time they do. Indian Ocean dipole is very warm temperatures in the Indian Ocean, so off the west coast of Australia. And we had the biggest IOD, or Indian Ocean dipole, on record in 2019. And that led to some really warm temperatures over the Western Australian coastline, Northwest Shelf and the reefs there.
Okay, excellent. This is a question for both of you. It's come from Michael. He wants to know, What is your work environment like? I'm sure he thinks that maybe you guys are diving off the reef every single day.
No, not me. My position is 90% in front of a computer. We access a lot of ocean information, but it all comes online through to us.
Yes, I'd like to be diving on the reef more than I am. We usually travel up to Townsville, where the Marine Park Authority is located, probably once or twice a year. At the start of summer, present our forecasts and are involved in the conversations for activities that will be planned for the upcoming summer. But alas, no, I'm in chilly Melbourne today and most of the time.
So not really ever getting to dive, guys. Have you been able to dive there for research before?
On holidays, not research.
Yeah, just recreationally.
Yeah,
Okay.
snorkeling. Yeah.
All right. So we've tamped down those expectations. We also had a question here from Edward. How dominant is temperature in bleaching? And I know you guys will be talking about this a little bit later on, but I thought maybe we could focus on the second part of the question. What opportunities are there for helping recovery?
Okay, so yes, we will be talking about temperature's role in mass coral bleaching. And in terms of recovery, yes, we'll also cover that as well. So reefs can recover if the conditions are right and if bleaching isn't too severe or too frequent.
Okay, excellent. And just off the back of that, Harley, and maybe this can go to you, Grant, they want to know maps of bleaching severity. Are they available online anywhere?
Yes, we'll be showing a couple of them in this presentation, and these all come from the ARC Centre of Excellence Coral Reef Studies from JCU. They're the ones that are also been released, or the 2021 has been released today as well.
Excellent. All right. So yeah, there was a couple of questions that we will be getting in more depth answer on coral bleaching later. But right now our poll results are in, and the overwhelming response is that the Great Barrier Reef is the same size as Italy. Guys, do you want to give us the actual answer?
The answer is E. So everyone's been reading it. Good on you all.
Wow.
It's
That's
the same
huge.
size as Italy. It's a massive.
Oh my goodness. So same size as Italy. That's a big area to cover, and obviously tons of information that you guys can shed on how you actually managed to cover all that size. Well, today's your opportunity really to talk to our experts, and we're aiming to answer as many questions as possible. So when one jumps into your head, put it straight in the chat box and we'll get to it as soon as we can. We have our producer who is rolling the questions through as soon as they come. But Claire, you're going to start us off by telling us by getting into our presentation. Please take it away.
Great, thanks, Jordan. So welcome, everyone. So today our webinar is in two parts, and the first part I'm going to start with is monitoring and predicting ocean temperatures. So what does that mean? How do we do it? And then what do we do with that information? So our oceans are warming. This is probably not news to most people. So on the plot on the left is from the Bureau's State of the Climate report that was put out in 2018, and this is showing the ocean temperature around Australia since 1910, and against a baseline of 1961 to 1990, and so that's showing that in the last 110 years, the oceans around Australia have warmed. On the right-hand side is from the IPCC, the Intergovernmental Panel for Climate Change, which is a huge international effort, put out a special report on oceans and cryosphere, so sea ice, last year. And this plot is from them. So this is showing climate projections, which is forecasting into the future for the next 80 years. And it's showing an increase in global mean sea surface temperature. So that's the average sea surface temperature around the world. And it's increasing under both the low emissions and high emissions scenario, and also marine heat wave days. So I guess the top panel is showing the baseline, so our background temperature is warming, and the marine heat wave days is our extreme temperature events. And we'll talk more about the impacts of these later in the webinar. So how do we actually measure ocean temperature though? As a scientist, I think some of these instruments are pretty cool. So on the left, you can see someone's dropping an instrument off the side of the ship there. So that is an XBT, or an expendable bathythermograph, if you want the full name. So that measures temperature. It drops down through the water column, converting water density to temperature. And this is these measurements are taken by a program called the Ships of Opportunity. And so these are merchant navy ships who takes these measurements for us. And you can see in the map below, there's orange and green stripes on it. That shows typical ship routes where these measurements are taken. That data then comes back to the Bureau and we use it in our data products and our modelling. Across from there, there's a nice yellow buoy. So there's moorings and buoys out in the ocean that are taking measurements and transmitting the measurements back to us via satellite. The yellow rocket looking thing underneath that is a glider. And these are programmed and they have a GPS and they travel up and down in the water column taking different measurements, and then they're retrieved at the end of their mission and that data is collected. And then on the right, the top picture is a picture of an Argo float. So these are really cool instruments. They get put out to sea, they last about 4 years and they cruise along at about 1 kilometre down into the water column so they don't get run over by a ship or fouled. And every 10 days, they go down to 2,000 metres depth or 2 kilometres and then rapidly ascend to the surface, taking measurements as they go. Then they pop to the surface and transmit all the measurements to satellite, which then comes into us in real time. So you can see that one's popped up to the surface and it's transmitting. And the map in the bottom shows each black dot corresponds to an Argo float. So this is another international cooperative effort. Various countries have put out Argo floats that then provide data and information about the current temperature and conditions in the ocean. Also, we've got ocean measurements from space. So this is one of the satellites that we use. So this is the Suomi MPP satellite put up by NOAA, which is the National Oceanographic and Atmospheric Administration in the US. And the images that I've got here are 3 daily pictures over the Great Barrier Reef of ocean temperature in the top surface layer. So this is from a service that the Bureau runs called Reef Temp Next Generation, which the Great Barrier Reef Marine Park Authority use to keep an eye on current temperatures over the reef. So, warming oceans. So what? A lot of people think, oh, you know, it's warmer for winter, warmer for swimming. So that's always good in Melbourne because it's always freezing. But, you know, there are impacts of that. Yes, it is warmer for swimming, but is that really what we want? So there are impacts of warming oceans, both the increasing baseline plus more extreme events or marine heat waves overlaying this warming baseline. So some of the impacts include mass coral bleaching, which will be the focus of our second part of this webinar. Thermal limits are exceeded, so a lot of marine species of coral and fish have a particular temperature range where they grow well or their productivity is highest, and that will can be exceeded in certain locations. Changes in growth rate and disease risk, they are strongly correlated with temperature. Habitat distributions, so fish and altered migration paths, so fish are turning up in areas where they may not have been found before or are migrating through locations sooner or later in the season, and also changes to spawning. Now, while this all sounds like it's happening in the future, a lot of this is actually happening now, and this is an example from Great Barrier Reef bleached in 2016, and this is just a newspaper article showing that we're seeing the impacts of warming oceans right now. So if the oceans are warming and there's more extreme events, what can we do about it? If we actually knew or stakeholders knew in advance that marine heat wave was going to occur, could they do something about it? So climate models can actually provide future information on ocean temperatures. And the timescales that we're talking about today are seasonal timescales. So in the image on the left, in the weather timescales, we're talking 1 to 7 days. This is when you would look at a weather forecast. So that's quite minimal warning time for managers or stakeholders to react to an event that's been forecast in the next couple of days. At the long term, we're talking climate forecast climate projections, tens to hundreds of years. So that's for long-term planning. For that in-between window of, say, 2 weeks to 6 months, having information about what ocean temperatures are going to be doing in that timescale provides an early window where managers and stakeholders, industry partners can actually implement strategies to minimise the impacts of these heat events. So what is a climate model? So basically climate models are computer models that predict future land, ocean and atmospheric conditions in 3D. They're based on physics. Well, the one that we're using is based on physics. And it includes a whole bunch of variables. So winds, ocean currents, rain, clouds, solar radiation, sea ice. It's a coupled model. You have an atmospheric model. It talks to an ocean model. A lot have sea ice models and also land models as well. And each of those does calculations that then feed information into the coupled models. And we also use the latest observations. So all those ocean observations that I was talking about a few slides ago, that is the information that goes into our climate model to give the best picture of how the ocean looks today. We then use those observations as well to see how good our forecasts were when we go back to assess that. So the Bureau Climate Model, so this is Access S for those who love acronyms. So this is the seasonal model that we are using. So essentially the entire globe is divided into a 3D grid. In the ocean model, which is where we're going to be talking about mostly today, our ocean grid size, if you imagine the entire ocean down to 6,000 metres deep, cut into cubes, the ocean grid cell size, that cube is about 25 kilometres by 25 kilometres in the horizontal. And right at the top layer is about 1 metre deep, and they go down to layers that are about 200 metres thick. And in each of those grid cells, all the physics calculations, all the physics equations are calculated. So that's 20 million ocean grid cells just in that model. So we need a really big computer to be running all of that. The models run every day and we forecast out to 6 months. So about our forecast in terms of accuracy. So forecast accuracy generally declines the further you look into the future. A lot of the assessment that we do about how accurate our forecasts are is we run a long series of retrospective forecasts, run back 20, 30, 40 years, and then compare to observations we have to see, did we predict these past events that have occurred? We also look at whether we capture trends and general features of large climate drivers such as ENSO, and also their impacts on other areas around Australia. So I think our animation is working. It wasn't working in our rehearsal, so you should be able to see in our left, on the left, that's daily sea surface temperature around Australia coming out of the model. And that's plotted at that grid cell resolution, so you can see all sorts of cool little features around Australia there. So now I'm going to pass over to Grant now, who's going to fill you in on our Ocean Temperature Outlook service. Thanks, Grant.
Thanks, Claire. So yeah, I'm just going to start by introducing one of the main Bureau services that we'll be mentioning several times throughout this presentation, which is our Ocean Temperature Outlooks. Sometimes we might use the word prediction or outlook or forecast. We're all pretty much mean the same thing. So this is a website, and the website is listed, the URL for the website is listed on this slide here that everyone can access. So it provides sea surface temperature information, forecasts for around Australia out to 6 months. So this is sitting in that seasonal timescale from fortnightly. So there is some fortnightly forecasts in there, first fortnight, second fortnight, and then from there it's monthly out to 6 months. So we've got forecasts for all around Australia, and the website has a series of menus. You can select the different regions. So if you want to have a better look at what's happening in a particular region, you don't have to just rely on the Australia-wide view. You can zoom right into a particular spot. This is updated twice a week on the website every 3 days. A new forecast appears. And alongside the outlooks, there is accuracy measures provided. So these are maps telling you how good the model is forecasting for that region at that time of year. We encourage everyone to use these skill maps alongside the forecast And on the website, there's a series of tabs with more information about this product, which will explain what all the parameters are and also how to use the accuracy measures alongside the outlooks for a particular application. So who would use these outlooks? Who would be interested? So we're going to focus a little bit on the use of this service for coral reefs, coral reef managers around Australia. So there's a significant portion of the Australia coastline that has coral reefs. So from the 2,300 kilometres of Queensland coastline where the Great Barrier Reef resides, we also have coral reefs in the Gulf of Carpentaria, across the top end, along the Kimberley and Pilbara regions, off the north of Western Australia, then around the corner at Exmouth, from Ningaloo, Shark Bay, all the way down to Perth, where there's soft corals off the coast there. But in other regions around Australia, there is also interest in this kind of sea surface temperature seasonal forecasting product, primarily fishery and aquaculture industries around in the Southern Ocean or along the east coast of Australia. So some of the fish that are identified in this slide, for example, tuna, salmon, swordfish, billfish, these are pelagic fish. They swim where they want to swim. So there's a particular condition or environmental conditions that they like to reside in. So particular temperatures that they're most comfortable in. And if those temperatures change, if those temperatures move to another region, well, then they're free to swim through those other regions. So you can see why managers of fisheries might be very much interested in this type of information. So what is, we really, the focus is on supporting the decision making here. One of the common questions I often hear about this, especially with regard to coral reef health, is what is the point of providing an outlook? There's nothing we can do as a short-term strategy to cool the ocean. Well, that might be the case, but there's other management activities that we can do surrounding the event. Some examples of these, for example, in terms of coral reef health, is where do we survey in the summer? If we know a particular region might be impacted, we can monitor this particular event and put the resources into this region. In terms of fisheries, a fisheries manager would be very interested to know the regions of interest for that particular year and also the timing of it. Is it going to be an earlier season? Is it going to be a later season? Is it going to be a bumper season? Do we need extra staff to manage this scale of this operation? And then several other management strategies very specific to the fisheries industry that can be made based on knowing the kind of information we can obtain from a sea surface temperature seasonal outlook.
Start, guys. I'm getting a really good idea about what is happening out there. But before we move on to part 2, I think it might be a good time to do our second poll and take some questions. If you've got something you'd like to ask, type it in now. But we'd like to know, what do you think coral bleaching means? Does it mean A, the coral has been faded by the sun, B, the coral is stressed, C, the coral is diseased, D, the coral is dead, or E, not sure? So it's your chance. On the side, you should have had that poll pop up by now. And while those answers trickle in, we've got some more questions. So this one comes from Richard. He wants to know the ocean temperature impacts on small reefs in the top end.
Yes, well, we have been talking about the Great Barrier Reef a little bit so far in this presentation, and also further into part 2, but the top end has also been impacted, especially during the El Nino events. Reefs like Scott Reef, which is quite a bit offshore, has been impacted with coral bleaching in 1998 and 2016, which were both coral bleaching, which were both El Nino years. And also other reefs like Ningaloo Reef is another one that's been impacted with significant events in the last 10 years as well.
So that was in an El Nino year, you said. What about in the opposite, when you have, I've just forgotten the term. What is it again?
La Nina.
Yeah, what happens then? Is the same kind of situation?
Yeah, well, not in the Great Barrier Reef, but there is quite a strong link between certain La Ninas in terms of what happens off the coast of Western Australia. So previously, in 2011, I think it was, Ningaloo Reef had a very significant event, and also all the way down the coast in Shark Bay, and impacted rock lobster industries and had several impacts. And that was all due to that La Nina event. Even though that happens primarily in the Pacific, you get warm temperatures flowing through the Indonesian through flow, and that goes all the way to the coast of Western Australia.
Okay, so Kaya, and I hope I've said that name correctly, they'd like to know, what role does extreme value theory play in the BOM's forecasting procedures or analysis?
Do you want to take that one, Grant?
Well, I mean, in terms of what we're doing, if we're referring to whether the events we're discussing are 1 in 10, 1 in 20, 1 in 50, 1 in 100-year events, that's not something we've done any kind of assessment on in terms of these sea surface temperature events. But I'm sure someone has done that kind of assessment.
Okay, all right, and hopefully it will be available somewhere online for you. Sorry we couldn't answer that for you. We've also got a question that's come from Graham, and I think this kind of dovetails onto what Kaya was saying. Is there any of the data collected about oceans, are they available online anywhere? Can you go and see a little bit more information about your particular grid?
Absolutely. Yes. So there's the ocean outlooks themselves that Grant's presented already. And then a lot of the ocean observations and data are all available through the Bureau webpage. So there's satellite data available through Reef Temp NextGen over the Great Barrier Reef. We've got a link on the last slide showing you where to access that. And there's also other satellite sea surface temperature products. There's short-term ocean forecasts as well from Ocean Maps. And there's also Argo and XBT, the expendable bathythermograph data available as well, both through us and through the global data centres as well.
Okay, so I wanted to ask a question. I'm going to jump in here. A couple of slides ago, you showed a map, and it looked like, I don't know how to describe it, like a poppy seed bagel. There was little dots all over the map that said this is where we can take measurements from with the little floating buoys. In Australia, or in the world actually, we have trouble getting along, right? I think that's pretty evident. How did everybody agree to let all of this information just be, I'm guessing it's shared by everyone, right?
Yep. So you're referring to the Argo program. So, so all those little black dots, we own a few of those. I forget how many. I'd like to say 200 or 300, but I'd have to check that. And then other countries, US, Japan, UK, quite a few others, all own different lots of floats. And there is a global effort that then all this data is then transmitted to their owners, and then that data is processed, and then all of it is uploaded to, there's 2 global data centres. And the idea is that by us contributing our data, we then have access to everyone else's data. So it's a global ocean. So we need to know what's going on everywhere, not just in our backyard, to be able to produce the best ocean forecast possible. So we need information about what's happening in the Atlantic, what's happening in the Pacific. And this is one of the ways that we can get access to that data.
All right, Dean might have jumped the gun here, but he wants to know, why are coral communities important?
Well, in terms of the Great Barrier Reef, for example, there's a huge economic benefit there of having a healthy coral reef in terms of tourism and supporting the fisheries industries. There's also another probably largely unknown benefit of having a healthy coral reef, in that coastlines with a fringing coral reef, the existence of that coral reef can remove energy from the incoming waves. So if you think about waves barreling in from the ocean, open ocean, it feels the coral reef is like friction underneath it. It slows those waves down. It removes energy from it, and so the waves that end up impacting the shore have less energy. So that means less erosion, less impact on infrastructure during storms. So there's that added benefit as well.
Okay, a lot of information to take in there. Thank you so much. We're going to finish off the poll now, and the answer is B. Most people think that coral is stressed. Is that correct?
That is
Yes, correct.
Gold star,
Okay.
everybody.
We have a really smart audience today. And there we have two really smart presenters as well. So if you have somebody some question that you'd like to get off your chest, put it in the chat now. You should be able to type in there. It'll go straight to our producer, who'll get it onto us so we can ask a question. We're going to have a big Q&A session coming up after part 2. So now's the time to start getting all those questions in. Grant, you're going to take it from here?
Yes, okay, let's lead into part 2, predicting coral bleaching risk. So what is coral bleaching? We've mentioned it a few times so far, but we haven't gone into what we're actually talking about here. So for anyone that doesn't know, coral bleaching refers to the loss of a particular algae that resides within the coral. So this is called zooxanthellae. I probably say that wrong every time, but it resides within the coral tissue and it has a symbiotic relationship with the coral, so it provides nutrients for the coral. And when the coral is stressed, it ejects this particular algae from it. And this algae also gives it its color. So without this color, the coral takes on a white or bleached appearance. So it's under stress, and bleached coral is a sign that this coral is unhealthy. Now, there are several factors that can stress a coral relating to temperature or maybe salinity or even too much light, but what we're focusing today on is mass coral bleaching, which is always caused by elevated ocean temperature. So even though you can get small-scale bleaching in isolated reefs based on other stressful factors, mass coral bleaching that occurs over regional scales is always caused by elevated ocean temperatures. Now, the severity of the event depends on the magnitude, so how hot the temperature in the water gets, how often it occurs at a particular reef, and how long the event goes on for. So a bleached coral is not dead. It can still recover depending on how long the event lasts for. So a coral can cope with warm ocean temperatures for a short term, days, weeks, is okay. When this elevated temperature stretches on to months to several months, that's when it can be a problem for the coral. And that's when bleaching is likely to occur. And if this event goes on too long of a significant magnitude, or it occurs in frequent succession, so we have a bleaching event, and then before the coral is completely recovered, we have another event, these can all be quite detrimental to the reefs. Great Barrier Reef, we have referred to it a few times. It's significant when we talk about coral bleaching risk because it has experienced several events in the last couple of decades. So 1998 and 2016 were El Nino years, and there was significant bleaching in these events, but also in 2002, 2017, and 2020, which were not El Nino years, bleaching also occurred. So the Great Barrier Reef is quite significant. We've already talked about how large it is, the size of Italy, 2,300 kilometers of coastline. It's worth 5.6 billion to the Australian economy, largely due to things like tourism and fisheries. So it's a very valuable asset. So let's focus now on some of the more recent events. So we've had 3 mass bleaching events in the Great Barrier Reef in the last 4 years. So March 2016 was a big El Nino year. Where coral bleaching was experienced, and also in March 2017. So we've got a plot here showing ocean temperature anomaly. So what we're looking at here is during the months of March in 2016 and 2017, how did the temperature differ to what is normal? Now we define normal as, in this particular case, as the time period from 1990 to 2012. So the average of what happened over all those Marches during those 2 decades is what we define as normal. So these plots are showing you how the temperature differed from normal. So those red colors, if you look at the color bar, the red colors go all the way from 0 up to a purple color of 2.5 degrees above normal. So in March, the highest temperature anomaly, deviation from what is normal, happened in the far north. And then in March 2017, there was patches of quite warm anomaly in the north as well as the central and southern regions. These were back-to-back events. So these are what we were talking about previously, where consecutive events can be quite detrimental to the reef because it hasn't had time to recover between the two events. Now, these maps here are showing, so these are from the ARC Centre of Excellence Coral Reef Studies. They're showing where the coral bleaching, following the surveys, where the coral bleaching occurred and was most severe in 2016 and 2017. Now, going hand in hand with those previous temperature anomaly maps, you can see that they line up quite closely with where the strongest, warmest anomalies were. So in 2016, most of that bleaching occurred in the far north, and then in 2017, we've got a bit in the far north as well as the central region. And then we've got some photos of the aftermath of the events from the Great Barrier Reef Marine Park Authority on the right there. So can we predict coral bleaching? Okay, so if we know that there's a link between the temperature and where the bleaching occurs, as seen in those two previous examples, then can we make a prediction of the ocean temperature? And therefore, from that, and knowing what we know about what thresholds of temperature are critical to bleaching, can we then provide some information on what the likely risk of bleaching is using some of these climate models? So the answer to that is yes, and we've seen the the slide previously where we've introduced our seasonal forecasting service for sea surface temperature around Australia. So this slide here is showing the example for the Great Barrier region and the Greater Coral Sea as well. So this is in that seasonal timescale showing monthly outlooks, and the colours tell you how much warmer or how much cooler than normal the ocean in the reef will be over that time period. Now, this is showing you the anomalies on a monthly scale, but it's not just this deviation from the average that's important, it's also the duration of the event that's important. So we also have some additional metrics on this website, as well as just your sea surface temperature outlooks. We've got some other metrics that are very specific to bleaching risk that are available on there, which take into account the duration of the event and how much that accumulation of thermal stress can impact the reef. Now, so the website has a series of tabs along the top that can provide more information on what these thermal metrics are and what they mean and how they could be used. So I encourage you to visit the website if you would like to learn more information. There's a lot of information available there.
Can I just interrupt quickly, Grant? Sorry, this is our first work from home webinar. So just wanted to make sure that everybody's receiving the chat window. We've had a couple of people say that they haven't been able to get through. So on the right-hand side, if you do have your chat window there, make sure that you send us through any questions that you have. And if you're not able to get through to the chat window, there are some some instructions up the top where you can hit view and then manage panels, and you should be able to get your chat box up there. So sorry to interrupt, please take it away.
Thanks. Now just a quick note on cyclones. So cyclones can cool down the ocean. So previously we talked about what happens in an El Nino year in the Great Barrier Reef, for example. There's a well-known link between elevated temperatures and the El Nino, but we're also seeing more events occurring in years where it is known as ENSO neutral. So El Nino Southern Oscillation neutral years. So in these years, it's other factors like warm temperatures, low cloud cover that isn't sheltering the ocean, as well as low winds. So winds can provide a mixing mechanism in the water. Without those winds, you can get a lot of accumulation of that warmth in the ocean. So that's what's happening in these years where there isn't an El Nino occurring. So what can cyclones do? Well, cyclones bring rain and wind and clouds to a region. So it has a benefit of cooling down the waters. And a good example of this was Cyclone Debbie in 2017. During that bleaching event, it came through towards the south of the Great Barrier Reef. So all that rain and cloud cover and mixing of the water, bringing that cooler, deeper water to the surface, cooled the reef and saved certain portions of the southern Great Barrier Reef from bleaching. However, a cyclone can cause a lot of damage to corals as well in certain regions, especially in the shallower, more coastal regions from strong waves coming in. So although it can cool the water and assist in alleviating that a bleaching event, it can also damage the reef from physical processes as well. And we also have these products available. So these are also linked from our Ocean Outlook webpage, but the links for these specific documents here are on this slide as well. So these are just 2 pages for the 2016 and 2017 bleaching events in terms of the ocean temperature, and provides a bit of a commentary on what actually occurred, the extent of the events, and what was the mechanisms that caused the event as well. So these are just 2-page documents which summarizes the conditions surrounding each of those events, and these are downloadable from the website. And I'll pass back over to Claire.
Okay, thanks, Grant. So then we've got this Outlook service, and then how does that information translate to our stakeholders and reef management? So we've had a really close working relationship with the Great Barrier Reef Marine Park Authority for over 10 years now in terms of forecasting ocean temperatures. And so every year, one of us or someone in our team presents the forecast for the upcoming summer at an annual pre-summer workshop that the Marine Park Authority hosts. And that's also attended by a lot of other reef management agencies and also tourism partners. And they use this workshop along with our forecast and other information that's presented to coordinate activities between agencies. So if the forecast is saying it looks like it's going to be a hot year, then the Marine Park Authority and other agencies will plan around that. It would be the year to do surveys and coordinate. Is a really big reef, as we've said. So resources need to be directed actively, I guess, to the areas that may be under threat. Or if it's going to be a normal year, so no bleaching, then those resources will be redirected into other activities. So we provide support throughout the year, but particularly through the summer to the Marine Park Authority and other related agencies. And one of the ways we do that is members of the Marine Park Authority Scientific Advisory Group. And this is a special group that is activated during a mass bleaching event that provides advice. We talk through our forecasts and also current conditions from reef temp in a weekly meeting that then allow the reef managers to take that information and plan their activities and responses. Further to that, as I said in the last slide, we're providing an advance warning or an early window to respond to increased coral bleaching risks, so high ocean temperatures. It gives time for managers to relocate resources, people in boats, or plan for aerial surveys if bleaching, if the conditions for bleaching have been predicted, then monitoring programs are then initiated, particular ones for a bleaching year. This forecast information is also used to brief governments, ministers, tourist operators, and as well as the general public, so people know what's going on and what to expect. A lot of this is done through the excellent Reef Help update video, which comes out every week by the Marine Park Authority and is hosted by Dr. David Wackenfeld, who's the chief scientist there. And that's a great overview of what is actually happening on the reef this week. And also our forecasts are used in that, as well as current conditions. And a lot of this work goes into if the reef management strategies are as good as they can be, this will improve recovery time and reef resilience, and also by reducing other stresses on affected areas. So what happened this summer? So this is what Jordan alluded to earlier at the start of the webinar. There's been a flurry of activity in the media about the reef. So February 2020 was one of the hottest months on record for the reef. So what I'm showing here in this panel is I've got satellite SST, so sea surface temperature, over the reef for February, and I've got our forecast next to that. So this year was different to 2016 and 2017 in that the ocean temperatures were warmer than normal across the entire reef. It was an ENSO neutral year, so there was no El Nino, no La Nina. But what led to the warm temperatures was basically less cloud, low wind, and very few tropical cyclones. So the water was sitting still under a warm, cloudless sky, baking under the sun. So we predicted these warm conditions a month ahead, which then that information was used by the Marine Park Authority and agencies to activate their coral bleaching response plans. In terms of bleaching, so aerial surveys have been going on. They've just been completed. So that happened in March and April, and that was through James Cook University. The extent of the damage is still being assessed, but there is significant and widespread coral bleaching has been noted. So on these two images, one is some underwater surveys that were done by the University of Queensland. That's a photo of Heron Island, and you can see the bleached corals there. And on the right is an aerial survey shot. You can see the shadow of the plane there. And this is if you're interested more about the actual bleaching that's happened this summer, the Marine Park Authority has put out a media release, and also James Cook University have also put out a conversation article, which I think will be put into the chat function later on. So if you're interested in the nitty-gritty of how the coral was impacted by these conditions, check those two sources out. And in terms of actually watching a bleaching event, often one of the really useful ways of using these forecasts is once the coral's gone white, you don't know when or how quickly it bleached. So by having a forecast, you can then keep an eye on the area that is predicted to have warmer temperatures, and managers can actually monitor bleaching as it's happening, and you can see which corals bleach first, which part of the reef is affected, how quickly it happens. And this documentary here, which has been put out on Netflix and has a whole bunch of preeminent coral and climate scientists working on it, actually shows the evolution of the 2016 bleaching event on the Great Barrier Reef. So I recommend checking it out, especially if you're all sitting at home and looking for ways to, expand your brain. It's a really interesting and quite a sobering documentary to check out. I think that's the end of our main content. So over to you, Jordan.
Thank you so much, guys. A lot of information there. It's been really excellent to find out a little bit more about what's happening in our own backyard, which happens to be the size of Italy. See, I learned something today. It's not often that you get two scientists in a room like this now, so we have a great opportunity to ask them some questions. Please start sending them in, and we'll get to as many as we can. We're going to start off with David. He wants to know, can you please define degree heating weeks or months, please?
Sure, I can do that. Yeah, so we did see degree heating months appear on a slide earlier. So what we're talking about there is the accumulation of the sea surface temperature anomaly over a 3-month period. Now, this isn't the normal anomaly I was referring to before. This is the anomaly of the temperature above what is known as the maximum monthly mean. So we work out what the maximum temperature is for a particular location for each year over a period of a decade or two, and then we average all of those maximums. So every year we look at what month the maximum temperature was. We average that over several years, and that's our maximum monthly mean. So during a particular forecast, we look at how much the temperature was above this maximum. And then we accumulate that. So we add it together over a 3-month window, and that becomes the degree heating months. And then degree heating weeks is very similar, but it is the accumulation over a 12-week window on a weekly basis. So rather than just adding 3 months together on a DHM or a degree heating month, we're looking at accumulating 12 weeks. So what's that anomaly over each week, over 12 weeks, and adding that all together to equal the degree heating week. So yes, it's a bit complicated, and there's more information on that on the website, on the Seasonal Outlook website. So if you go there, then one of the tab is listed as product information. So there's more information on the degree heating months there, and more information on the maximum monthly mean there as well.
Okay, excellent. Kaya has asked, are the frequency of cyclones dependable enough for their cooling effects?
No.
No.
I know during this particular summer, for example, when the temperature in the GBR really, in the Great Barrier Reef really started to warm up from mid-February onwards, I was monitoring the cyclone outlooks, thinking surely there's going to be a cyclone that's going to cool things down. And there was Cyclone Gretel in, I think it was more towards mid-March, but it was just too late. And also it just crossed the coast in one particular region, so it didn't do that much cooling across the Great Barrier Reef as a whole anyway.
Okay. John has asked, do ocean temperatures warm at the same time around Australia?
No, is the short answer, I guess.
So the longer answer, more detail. It's actually a really good question because it's not something many people would know. But we know that we experience summer in Australia as a whole, but in terms of when the maximum temperature is, it changes around Australia. So along the east coast, the maximum temperatures are felt in February. So that's most of the Great Barrier Reef. But then far north Great Barrier Reef and Gulf of Carpentaria, the maximum temperature is in January. Across the top end, it can be December and November, and then most of Western Australia it occurs in March. So no, it's different everywhere.
The variability is also different. So some areas can warm up and cool down by quite a big range, and that's normal. And the marine species that live there and the fish that pass through are used to that because that's what they experience all the time. And in other areas around Australia, that temperature range is really quite small. And so 1 degree above normal or average doesn't mean the same thing everywhere.
Okay, because that's what Wayne's actually asked. The changes in ocean temperatures that are happening don't seem big in terms of numbers. Why do these small changes have such a big impact?
Well, I guess that's the reason. So in some areas where you might see big swings in temperature, both just during the day and also from season to season, the species that are there, the fisheries that are there, they're used to this and they've adapted to live in that kind of environment. Whereas on the Great Barrier Reef, the usual temperature range from the south through to the north over the year might be from 24 degrees maybe to 28, 29 degrees. So there's not a big range. So you add a couple of degrees on top of that, and that's pushing the species, the corals that are in those locations well out of basically their comfort zone.
Okay, it's really interesting. So Kaya, I'm so sorry. She's either going to be extremely excited because she's getting another question answered, or I've said her name wrong so many times. Have you observed coral drifting away from regions that are getting warmer over the years, maybe to like a slightly colder place?
I mean, yeah, I've seen this mentioned as a possible outcome of temperature changes. I guess it's a very slow-moving event if it was to occur. I mean, so there is documented species changing location. For example, there's lobsters appearing in regions around Tasmania where they previously didn't inhabit, and other species as well along the east coast that have been found further south.
But yeah, corals take a really, really long time to grow in general.
Okay.
Reef
Can
does, so yeah.
Can you give me a little bit more of a definition on that? Because that's the exact question Ben has asked. How long does it take for a new one to grow?
For a whole reef, you're talking hundreds to thousands of years. There's all sorts of different species of coral. It's a bit like your backyard in your garden. You get the weed types that grow quite quick, and they usually come back after you've mowed the lawn or the coral's been bleached, I guess, for an analogy. And then there's other bigger, slow-growing ones that that take a lot longer to grow. They might be tougher because they don't bleach as quickly, but they also take a long time to grow and a long time to replace should they die off. So the reef is there's a lot of different types of coral, a lot of different types of species. It's really biodiverse, and that's one of its strengths in that species will respond in different ways. So, and I think that's one of the outcomes that's come out of the aerial surveys this summer, if people want to go and check that out, where the researchers in those articles talk about how different species have been affected differently and respond differently to those ocean temperatures.
Okay, excellent. Okay, so Jeff might feel a little bit inspired by everything that's going on. He said, what opportunities exist for citizen scientists to assist in monitoring and or lessening the damaging from a warming ocean on those reefs?
Oh, great question. So the Marine Park Authority has an excellent citizen science program called Eye on the Reef. You can download the app on your phone. So if you're out on the boat or you're doing some snorkeling or visiting the reef, it's a way of recording what you see and then providing it back to reef managers. And given the size of the reef, they rely heavily on citizen science and tourism operators as well as general public. So you can basically submit your information and that all goes into their assessments. So if you're interested
Fantastic.
in that, check out the Marine Park Authority because that is a great program.
All right. So 2 notes while we wrap it up because we have run out of time today. Kaya has said, thanks for answering my questions and pronouncing my name as well. So that's a little win for me.
Oh, that's good.
And Fred has said, any questions? Sounds like you know your GBR well, Great Barrier Reef well. So well done, guys. If you didn't have the ability to ask one of those questions, then we will have an email coming up in just a second for you to be able to contact us. But that's all we have for today, guys. It's been really illuminating, but before we do push off, we thought maybe it'd be good to do a quick summary of everything that you missed in case you didn't get the opportunity to join us at the start.
Great, thanks, Jordan. So just echoing, I guess, the outline we had at the beginning of the webinar. So elevated ocean temperatures, both a warming baseline and marine heat waves or extreme events impact coral reefs, which has been focus of our talk today, as well as aquaculture and fisheries. And we can use ocean temperature forecasts to help manage these impacts. So to provide advanced warning and early window for action and management strategies to be implemented to help minimise these impacts. And reef managers and stakeholders use these forecasts from our ocean outlooks to help plan and coordinate bleaching responses. So for those who've missed it, the link to the Outlook service is on the slide. If you're interested in more coral bleaching and physiology and what's happened this summer, check out the Marine Park Authority's website as well as James Cook University as well. There's some great information there. So that also brings me to the next slide where there's some more info. So there's the outlooks. That's out to 6 months. We've got Reef Temp Next Generation, which is our satellite images of today's temperature on the reef. There's the State of the Climate, which has some information on climate change and impacts on oceans. Great Barrier Reef Marine Park Authority is a fountain of knowledge on all things reef, including the reef health updates, which are great. I recommend tuning into those. They happen weekly on a Thursday. And there's also the Chasing Coral documentary, which is a really excellent watch. So I'll hand it over to Jordan and he can do all the social media and webinar chit chat. So
Yeah, thank you very much. We had a great time today. I've definitely learned a lot, and that brings us to the end of the webinar. So for questions that we didn't get to, weatherquestions@bom.gov.au. That's weatherquestions, one word, at bom.gov.au. A huge thank you to Claire and Grant for your time in developing the content and sharing your knowledge with us. And to you, thank you for tuning in and joining us today. We hope you enjoyed this session, and we do hope that you'll join us again next time. And if you continue the conversation online, use hashtag BOM Webinars in your LinkedIn posts. So as mentioned earlier, this session has been recorded, and we will have the video ready for your on-demand viewing pleasure in the next couple of days. So watch this space. And finally, but most importantly, we want your feedback. It is our aim to bring you the highest quality webinars, but we can't do that unless you share your experience with us. So once this webinar is finished, a short survey will pop up, and we would really appreciate if you would fill that out for us. Big news, though, is that we do have another webinar in the works. It's going to be on the 5th of May, and it's focused on how does a weather radar work? Another one where a lot of people send us questions about this, so we're really excited to share with you how it works and talk about the new one the Bureau has just built. There is a registration link that is now available in the chat, so you can click there, register now, and join us. Again, that's it for today. Thank you so much for joining us, and we look forward to seeing you again soon. Goodbye.
Thanks, everyone.